So now we're going to continue looking at Chapter 12 in a quick recap, and we're going to go over the arithmetic and geometric sequences. So let me start with just a simple example of an arithmetic sequence. Let me just write the numbers 10, 12, 14, 16, and 18, and we could just keep going. And this is arithmetic. I think it's, hopefully you remember why. If we look at each term, it is 2 more than the term before, so we can keep adding 2. We had a name for that. That meant that the common difference was 2. And we used the letter D for that. So D was equal to 2. This was a sequence that had a starting value of 10. So we just said that the first term, or A, is equal to 10. And so with this, we just keep jumping by 2 to get from one term to the next. So if I said, what is A3? You can just look right on the list of numbers there. You get to say, oh, A3 is 14 just by looking at the list. Now, if I wanted to jump further ahead, if I said, what is A20? You could just keep writing the list of numbers. It's a relatively simple one to do, but it's not always simple. And if I'd asked for A2000, you wouldn't want to just list the numbers out. So you probably, if you wanted to find A20, you would want to go back and remember that we can find for an arithmetic sequence any term in the sequence by taking the starting value plus the common difference n minus 1 times. Now remember, the n minus 1 was because we didn't apply the difference. We didn't have to add the difference for term 1. We start when n equals 2, we add d once. And when n equals 3, we add d twice, and so on. So that's why we have the n minus 1 in there. So let's apply this to finding A20. If I wanted to find A20, I would know that we had started with a 10, and we're going to have a common difference of 2. And we're going to apply that 20 minus 1 times. We're going to add the 2 on 19 more times. So that will be 10 plus 2 times 19, which will be 10 plus 38, or 48. So the 20th term would be 48. So we've answered the question. Now, other interesting things, we're going up by 2s. You could ask, well, what term is A of n equal to, let's just go to 100. So if we wanted to know what term it is when the term value goes to 100, we could use the same formula and we would know, in this case, A of n is 100. We know we started at 10. We know we keep going up by 2s, n minus 1 times. So we can just solve for n. We can say 90 is equal to 2 times n minus 1. Divide by 2, so 45 is equal to n minus 1. So n must be 46. So on the 46th term, the term value would be 100. So we could do that. Now we could continue with this. We can talk about the partial sums. Okay, so in this case, if I asked for, let me write out the sequence again just real quickly. So the sequence had been 10, 12, 14, 16, 18, and so forth. So if I wanted to find the third partial sum, that would just be 10 plus 12 plus 14. So that looks like 22 plus 14 is 36, if I did the math correctly. So we could just add up the 3 terms. But if I wanted to find S20, it would be a little bit more tedious to add 10 plus 12 plus 14 and keep going all the way to the 20th term, which we had determined would be a value of 48. But we'd have to keep adding up all of those values, and the number will be much larger. So if I'm going to find this, I want to recall that we had a couple of additional formulas. We had the formula that S of n was equal to n times a plus a sub n over 2. Quick recap, if you look at the n and over 2, we could say, if we took the first term and the last term and add them together, and then we took, we'll get a total, and then if you took the second term and the second to last term, you get the same total, and you end up with the number in the list divided by 2 pairs that add up to that total. But another way to look at this had been, well, what if we group it like this? If you take the first number plus the last number and divide by 2, it ends up giving you the average value of the numbers in the list. So if you multiply that by the numbers in the list, you'll also get the total. Or another way to think of it, we said if we took the 2 over to the other side, twice the sum was equal to n times a plus a of n, because we had learned, oh yes, you could add the list if we're doing the numbers 10 plus 12 plus 14 all the way up to the 20th term. That would be 48. We could reverse the list, and this is what we had done in the Gauss example. And we would be going all the way down to the last number, which was 10. And so you would see that every time we add these numbers up, we would get 58. So we would have n values of 58 added together. There would be n terms of that, but that would be twice the sum because we had added the list forward and backwards. So this formula was useful. If we substitute, let's make a little formula list. If we write that formula 1 was the formula for the terms, a of n equals a plus d times n minus 1. And formula 2 is the one we just came up with, the partial sum of a arithmetic series can be given by this. If you substitute equation 1 into equation 2, you can get an equation 3, which is that the partial sum is equal to n over 2 times twice a plus d times n minus 1. And depending on what example you're looking at, you're going to choose different, what you pick out of equations 1, 2, and 3 will depend upon what's given in the problem. So let's look at a quick example where we might use that. Okay, so let's just look at the example. What if I've been given the list? Here's another example. If I had the list 5, actually, let's make this a partial sum. So let's just call it 5 plus 10 plus 15 plus ... all the way up to 200. Okay, so if we look at this, we could use possibly formula number 2, except we don't know what n is. Okay, so n is a question mark. Okay, so that actually rules out using formula 2 or formula 3 for now. So the only thing left is to use formula 1 to determine what n is, and then we could probably use formula 2 from there. So if I look at this, I can say a sub n is equal to a plus d times n minus 1. So the last term is 200. So we'll call that a of n. The first term was 5. The common difference is 5. And we'll have n minus 1. So 195 is equal to 5 times n minus 1. divided by 5, and you get 39. Let me just double check. Yes, 39 times 5 would work. That has to equal n minus 1. So n must be 40. So we now know there are 40 terms. Now that's not the answer to the question. What we now need to do is determine what those add up to. So now I could use formula 2. So I can say S of n is equal to n times a plus a sub n all over 2, and I now have the numbers. So this is the 40th partial sum. It would be equal to 40. The first term was 5, the last term was 200. We'll put that over 2. Probably the easiest thing is to take the 40 and divide by 2. So S of 40, if we're doing this mentally, is 20 times 205. So that looks like it would be 4,010. So that's what the sum of the first 40 terms would give us.